Okay, so now we're going to continue on 48 on 6-4, and this one says y equal 3 cosine x plus 2. So this is the first one that has a vertical shift. You notice this little plus 2 means it's going to be a vertical shift. And so you're going to have a middle line at y equal 2. So let's see. 3 cosine x plus 2. We know our amplitude is 3. Oh, is it frozen? Yeah, it is. My bad. Okay. So 48, y equal 3 cosine x plus 2. So based on this part here, you've got a vertical shift, and your middle line is at 2. You've got an amplitude of 3. From the number in front, you've got w as 1, because that's the number in front of x. You know, you just assume it's 1, like a coefficient of 1. So when you figure out your period to be the normal period divided by w, in this case it would just be 2 pi divided by 1, which is 2 pi. So because of that, we don't need to change any of these numbers down below. We're going from negative 2 pi, which is over here, to positive 2 pi. And we don't need to change any of the tick marks. So if we have an amplitude of 3 and our middle line is at 2, let's just plan this out. If we put a 2 middle line here, and then from 1, 2, then you'd have to count up 3, 1, 2, 3, you'd be off the page. And so we can't really count by ones on this. Because of that, we want to count by 2s. So we go 2, 4, 6, and really we're going to want 5 for our maximum. Because think of 3 plus 2 is 5. And then count by 2s down here, so negative 2, negative 4, negative 6. No, good question. We don't have to change the x's because our period's 2 pi. We're going to show 2 periods worth. So we don't have to change our x's, but this might be the first time you have to change your y scale to count by 2s. Okay, so let's do our middle line. I just do a dashed line like this. By the way, before I get into it too much, remember that you can graph it on the calculator as well. And you have 3 cosine x, and then go outside the parentheses, then do plus 2. So that's what it looks like in radian mode. If you were in degree mode, it's going to look flat, which is wrong. Okay, so make sure when you're graphing it, you want to use radian mode for it to be curvy. The other thing we mentioned is you'd want to use a trig window instead of from negative 10 to 10. So window, and then the trig window is number 8. And so there's that. And we're going to use from negative 6 to 6 for ours. Window settings, negative 6 to 6. Okay, so it's basically going to look like that. And if we think about the plus 2 being here, y equal 2, then now you may have a little better understanding. You're going to be up 3 and you're going to be down 3 from the middle line. Up 3 and down 3 from the middle line. So because your amplitude's 3. Normally our middle line is at the x-axis, so then we just go up 3 and down 3. But this is the first one where there's actually a shift, a vertical shift.
Wait, how do you add the 2?
So on your tab, I just put f2 of x equal 2. So that's how you make a horizontal line. Yeah, that's how you make your horizontal line. Your first one would be blue, your second one red. Yeah. Okay, so then the other thing, remember you can do Control-T to get in the table. And most of the numbers are not going to make sense because we need these numbers, which is why I usually just do it by hand instead of the calculator. But you do see that 0, 5 is what we want to start with. So 0, 5 is this dot. Okay, from there we're just going to follow the cosine pattern. And so cosine starts high, and then at this point it would touch the middle line right there. And at this point it would come down 3 units. And so that's basically, if you think of it this way, it's 1.5 blocks. You know, because I'm counting by 2 and I need to go to 5. So that's 3 units. So to count down 3 units, it'd be 1.5 blocks to right there, which is where -1 is. So basically think about your range to be from -1 to 5. So our graph is going to go from that to that instead of just from -3 to 3 based on the +2. So now follow the pattern here, middle, down, middle, and then up at 5. And that's this part. Remember to make these smooth if possible. Try not to make points or sharp edges. And then we just need to follow the pattern still. So this one comes down to the middle, and on this one it goes 1.5 blocks down to where -1 is, and then it comes back up, and then up to this. So sort of like that. And the main point I want to emphasize is it starts at 0, 5. So this is a cosine graph. Remember different things that we've said before, different attributes, like it's reflected across the y-axis, not the x-axis, and not the origin. Okay, so there's 48. 52. On this one, our equation is y equal -3 cosine pi force x close parentheses +2. Remember, if when you were typing it, you forgot your x, it would just be a flat line even if you're in radian mode. So make sure you're typing your x's. Okay, so what we know is our amplitude would be +3 because amplitude has to be positive. So you do your absolute value. We know that based on this, our middle is at 2. Middle is at y equal 2. We know our w is pi force, because that's the number in front of x. And then to do our period, we use period as the normal period, which is 2 pi, except for if it's tangent or cotangent, divided by the number in front, which was a pi force. So at this point, you want to multiply your 2 pi times 4, and you get 8 pi. And then your 1, which is kind of understood to be like down below the 2 pi, like that. 1 times pi is pi. So your pi's cancel and you end up with 8. So this is one of your first ones that you actually have a period that doesn't have pi in it. Remember what we've said is if your W has pi, then your period doesn't. They're opposites in that respect. If your W did have, if your W has pi, your period doesn't. If your W doesn't have pi, like it didn't on this one, where it was just 1, then your period did have pi. So again, they're opposites. Okay, let's see. On this one, we're going to have to change our horizontal marks because our period's 8. So let's mark these out. And we're trying to show 2 periods worth. And so if this is where 0 is, I need to say 8 is over here. And you take half of 8 and you get 4. So 4 is this one. And then half of 4 is 2. Then you can think, I'm going to go 2, 4, 6, 8. So this one's going to be 6. And then just resume that over here. I think our pattern has been that we change the right side but not the left. We just mark them out. It would be this as -2, -4, -6, and -8. So that's adjusting our horizontal scale or X scale. Any questions? Okay, we also know that the original part was -3, so that's meant it reflects the x-axis. It reflects the x-axis. And here's what that graph is going to look like. -3 cosine pi force I want an extra parentheses there and put the x right after that, like that, and then +2. Okay, so that's generally what our graph is going to look like. If we look at our table, yeah, it is upside down. Yeah, because it reflects. Our table has a couple of points we may want to use, like 0, -1, 2, 2, and 4, 5. Those actually look like good points. I don't want to use the decimal points because it's hard to, it's not as accurate, so to speak. Okay, so those are things we need to keep in mind. Let's do our counting by 2s like we did before. So we've got 2, 4, 6, -2, -4, -6. Okay, so our middle line is at y = 2. Let's mark that this way with a dashed line. Okay, and then our amplitude's 3, so we're going to go down 1.5 blocks, and this point lines up with the 0, -1. So this is going to be our lowest point. That's the start. From there it's going to go up, and that's going to be at 2, 2. And then 4, 5 would be here, and then back down, and then to here. So make that smooth and continuous, like that. So that's one period worth. Now let's do the next one. So at -2, it'd be back to in the middle. And then at this one, it'd be above to 5, because we're doing 2 plus 3, because our amplitude was 3. Then we go back down to the middle, and then end up over here. Then just make it smooth and continuous. Okay, so that's what it looks like. Now, I believe on your Math Excel on this, you're going to have to have a little box that shows amplitude, and that's where you type a 3. There's a place where it says reflect X, and so you're going to have to do a check mark. It's going to ask vertical shift, and you're going to say 2, because that's the +2. There's going to be a place where it says period, and you're going to put 8 in this case. There's a place where it says reflect Y, but keep it unchecked. And then there's something about a horizontal shift, and leave it blank, because we're not doing pi force x plus or minus 1 or plus or minus a number. So leave the horizontal part blank, as well as reflecting the y. Any questions about those? Okay. Also, you're able to type in coordinates on your graph and just choose the correct, choose whether it's sine or cosine, also in Math Excel. So cosine would be the one like this, and sine would be the one like that. Yeah. Okay, so that's how you do it on Math Excel as well. And now let's move on to number 60. Okay, so for number 60, this one, you're given an amplitude of 2 and a period that's 4 pi. And what the directions are is to write the sinusoidal equation, which is really just the sine equation. It's just a fancy word, sinusoidal, which is sine. So what we know about this is our A is 2, our T, which is our period, is 4 pi. And in order to write the equation, we've got to figure out what W is. So we need W. So we have period is normal period divided by W. In this case, we already know our T is 4 pi. So we put 4 pi here. Remember that your normal period would be 2 pi except for tan and cotan. So we put 2 pi here. Pi. Yeah. And then it's 2 pi if it's sine, cosine, cosecant, or secant. Yeah. Okay, good. Now you want to solve for W. So that means you're going to multiply by W and divide by 4 pi. So we get W equal 2 pi divided by 4 pi, which is 1/2. So that's basically all you need to know how to write the equation. It's just going to be y equal 2, because it's an amplitude of 2. Then you put sine. Then we put our half. And don't forget the x.
Do that in like the rest of the steps, the W equals 2 pi, 1, 30, 25,
I'm not sure I know what you mean.
like, don't skip multiplying, like,
Well, I did the 2 pi divided by 4 pi because I multiplied by w and I divided by 4 pi. Oh, okay. Okay, so here 4 pi equal 2 pi divided by w. Multiply by w, so you get 4 pi w equal 2 pi. Does that make more sense?
Yeah.
Okay, so now we want to divide by 4 pi to cancel it. So then that turns into a half. Basically, whenever you have your variables on bottom, these things end up switching places.
Okay.
Yeah, because you're going to multiply by w and then divide by 4 pi. Okay, good. So this is your answer. Now, 62, this one you're given an amplitude is 4 and a period is 1. So these are ones where you're not doing every other even, you're just doing evens here. So what we know to start with is it's going to be 4 sine something. We've got to figure out what the w is. So remember we do period is normal period divided by w. If our period is 1, then we get 1 equal 2 pi over w. So at this step, let's multiply by w. So you get 1w or w1, which is just w. And then your w's cancel, so you get 2 pi. So you have 4 sine parentheses 2 pi x. And that's your answer. So if they give you the amplitude and period, your goal should be find w. So that's why I said need w on that one. And same thing here. You need w. Okay, 64. This one, you're given graphs in the book. And so let me open up to the correct page. 64 on section 6.4. Okay, so this is a student edition book, so I don't have the key showing. This is what your graph is for 64. Notice it goes through the origin, right? And it is a sine graph. Yes, good. Yeah. Yeah, and then it also goes through 4, and it also goes through 8. So think about it increasing here at 0, and it's also increasing here at 8 pi. That means our period is going to be from 0 to 8 pi, which is 8 pi. Okay, you got to figure out your period, which is the horizontal distance. You could also do from the top to the top. So in this case, 10 pi minus 2 pi is 8 pi. Or you can go from bottom to bottom. So negative 2 plus 8 gives you 6. So again, that's 8 pi for your period. We also can see that our maximum is at 4, so our amplitude is at 4. All right, so based on that graph, we need to start writing down some attributes and then write our equation. So this was on page 411 if you want to look at that. We know our amplitude was 4, our period was 8 pi. Since we went 0 to 8 pi, or other ways like negative 2 pi to 6 pi, etc. So then, just like the ones above, we have our amplitude and period, so now we need our W. So we need W. So that'd be period is the normal period divided by W. 8 pi equal 2 pi divided by W. Yeah, that's it's an easy formula, but it's one you definitely need to remember. Period is the normal period. It's not n times p. It's just the normal period, which is 2 pi divided by W. So then we're going to multiply by W. So it looks like that. And then divide by 8 pi. So then we get W equal 2 pi divided by 8 pi. So your pi's cancel, and you get 1/4. So W is 1/4. Based on that, our equation would be y equal 4 from your amplitude, then sine 1/4 x. 4 sine 1/4 x. Any questions? Okay, 66. This time you have this graph. It's coming down, so it looks like it's a reflected sine graph. It still goes through the origin. That's how I know it's sine. Okay, if it goes through the origin, it's sine. And this time, instead of going up first like it did on this one, it's going down to the right of 0. And so, like, if you think of it this way, it's going down first if you cover that up. So that's how I know it's a reflected sine graph. And we know our amplitude's 2, and we know our period is, from 0 to 4, so 4. Very good. So this one, notice you're counting by whole numbers, or integers in this case, because negative whole numbers. But it doesn't have pi like that one does. Okay, so what we do is write down some of our features. We have our amplitude is 2, our period is 4. It goes through the origin, so it's a reflected sine graph since it reflects the x-axis. So those are different attributes. So we know it's going to start with y equal negative because it reflects the x-axis, and then we put the 2. Then we have sine, and it's going to be something with x right there. So again, our first step is we need W. So period is normal period divided by W. So your W would be the 2 pi divided by 4. So that's pi halves. So we get pi halves right there. And that's our answer. So the two versions of this equation are T equal NP over W and W equal NP over T. So if you want to think about those two equations, that's why we do 2 pi over 4. That might be easier for you to remember W equal NP over T. That way you just plug in what you have. Any questions?
What's W equals 2 what over 4?
2 pi over 4. 2 pi. Normal period's always 2 pi except for tan or cotan. Oops, that just went blank for a second. Okay.
Teachers and students, pardon the interruption.
All right. So now we have our equation y equal -2 sine pi halves x. Okay. Were there any other questions on 66? Okay. Okay, 68. On this one, this is your graph. Oops, I was pointing up here. I should have gone to 68, which is over here. Yeah. All right. So basically on this one, your amplitude for 68 is going to be 5 halves because you're going up 5 halves and down 5 halves from your middle line, which is y equal 0, because that's the x-axis. And your period is from, like, thinking about this one, the middle to the middle, so from 0 to 2. So your period's 2. Also, that was an upside down graph, if you noticed, because it started low instead of high. Yeah, so that means it's going to be a reflected cosine graph. Okay, because it doesn't go through the origin. If it goes through the origin, it's sine. If it goes through the high or low, it's cosine, since we're not doing horizontal shifts. Okay, good question. So this one, well, I could write that also. If it's origin, it's going to be sine. If it's high or low, then it's going to be cosine, since no horizontal shifts. Okay, so this would be a reflected cosine graph, and we know our amplitude is 5 halves and our period is 2. So we know the start of this would look like y equal -5 halves, because it reflects across the x-axis. We got our negative, we got our 5 halves, and it's going to be cosine something, and you have your x. So that's the start of it. The next step, if we build on what we did, period is normal period divided by W, which means W is the normal period divided by T. So your normal period is 2 pi, and your period is 2, so that cancels and you get pi. So we have pi x. Any questions? Okay. 70 is here. Again, it's not through the origin, so it's not sine. It's down, so it's going to be a reflected cosine graph. And our period goes from 0 to 2 pi, because that's from low to low. And our amplitude is pi in this case, which is weird, but pi is just a number. So pi is our amplitude. Okay, so yeah, that's right. So we have a reflected cosine. Our amplitude is pi, and our period is 2 pi. So we know it's going to start with y equal -pi cosine. Then I'll just wait to fill in this other part. Okay, so we have our period is normal period divided by W. So W is your normal period divided by T. So that's like solving for W, like we've done a couple of times. And then we get 2 pi divided by 2 pi. So that means it's 1, right? So you can either put 1x, or usually we just leave the 1 off. So it's just negative pi cosine x. Remember, like before, if you want to graph these on the calculator to compare, you can. So again, make sure you're in radian mode, and we think the answer is negative pi. Remember, you can press the pi button there. Negative pi cosine. So we press the trig button, go cosine x, and it looks like this. Control T for table. It's 0, negative 3.14, so that's negative pi. Remember, you can also change your table settings to be more meaningful. You want to start at 0 and step by, in that one we're stepping by pi halves. Pi divided by 2. So you could do it that way, where you can see that it's negative pi 0, etc. So remember, you can do that, or you can just change it to ask mode if you'd like. Independent to ask. That way it'd be blank. And so if you want to type in 0, figure out that. If you wanted to do pi fourths, that wasn't useful at all. Pi thirds is not useful. Well, it's like basically negative 1.57, but pi halves would be back to 0, and so forth. So you can plug in whatever you want. And that graph does match what was in the book. Okay, 72. This is our last problem, and it's probably the hardest simply because there's a vertical shift down, and so it looks like the negative 1 is going to be your middle line. So what we have for this one is a middle line that's y equal negative 1. So it goes through that middle line right there. So that indicates it's going to be a sine graph because it's not above or below the negative 1. And it's also reflected across the x-axis because it's going down. So we know this is a reflected sine graph because it goes through the middle. And our amplitude is a half, so that means we're going to get y equal negative 1/2 sine something x minus 1. And then we have to do our period is normal period divided by w, and then plug in. So your period on this one goes from 0 to 4 pi thirds. So 4 pi thirds equal 2 pi over w. So then, I'm still recording, so I'd appreciate quiet.
Oh, you're recording?
So then we got 2 pi divided by parentheses 4 pi thirds. And then that makes it 2 pi over 1 divided by 4 pi over 3. So you get 6 pi over 4 pi, which is 3 halves. So that's going to be 3 halves x minus 1. Okay, so now we're done with that lesson.